So here's a graphing problem. This is the kind of thing that you should be able to do on your own time. It's not something that would take to do the whole thing for on the test. Anyway, so what we have to do is figure out what the scales are. Here I have millimeters and seconds, and if I'm thinking of what the slope would be, if I wanted the slope to be something meaningful, millimeters per second would be meaningful, because that would be like a rate. Millimeters per second, same thing like, meters per second. So in that case, this would be x, and then this would be y. So my x, I have to go from 0 to 5. And so I have little marks on here already because it took a while to figure that out. So that would be 0, here maybe would be 1, this would be 2, this would be 3, this would be 4, this would be 5. So I had to figure out by counting the little squares right here that here's 10 squares, here's another 10 squares, like that. Then on the y-axis I have to go from 9, well pretty much 0, all the way to maybe about 50. So again, I did that over here. These would be seconds, this would be millimeters. So maybe here's, let's see, 10, 20, 30, 40, 50, right? So here's 0, that would be 10, 20, that would be 30, this would be 40, and then this would be 50. And if I wanted to, I could get a straight edge over here and make those lines darker. So I don't confuse myself. Now I have to plot the points. So when x is 0, y is 9. So that's about, let's see, here, okay? So when s is 1, this is 13. So let's see, 10 would be 11, 12, 13 would be about right here, so something like that. So when it's 2, then I have 20, so 20 would be here and about right there. Then 3 would be 31. So here's 31 over here, so 3 is about right there, 31. And 4 is going to be 40, so I might want to do this now. Mark my 4, and my 40 would be over here. And then 5 would be 49. Here's 50 minus 1. Okay, so let's see, did I do that one right? 9 should be about right here. So anyway, now I'm going to get the best line through these data points I can. I don't want to do just this. I mean, that looks pretty good for those 4 points there, but these 2 points are then off. If I know it's supposed to be a straight line, then those all have equal weight. This and these all have the same equal weight. So maybe it's going to look something like this. You're not going to get it exact. If you had to do that, you'd have to use a computer program called least squares fit. So now, what information do I need to describe this line? I'm going to write the equation for the line. It's the line. It has nothing to do with the data points. I use the data points to get the line. After that, I don't use the data points ever again. So to get the slope is the change in y divided by the change in x. So I need to take 2 data points to calculate this. So probably I'll take, let's see, where's one that's fairly close to a line. Hard to say. Well, I'll just take this one and say this one, okay? So at 4, I'm getting pretty close to 40. So that's 40. And then this one over here is, let's see, 5, 6, 7. I'm just going to say 8. So the data points I used were 4 down here and 0 over here. Okay, so this would give me 32, and of course y is millimeters, and this would give me 4 seconds. So the slope of this line is that for every 32 meters, millimeters, it takes 4 seconds. So the slope of that line then would be 32 divided by 4 is about 8. So maybe 8.0 millimeters per second is the slope. Well, what is the intercept? The intercept, known as b, I can read right off of this right here. So that's about 5, 6, 7. It's fairly close to 8, so I'm going to say the intercept is about 8, and the units would be millimeters. So the slope of the line is going to be y is equal to mx plus b. So for this particular line, it's going to be 8.0 millimeters per second, whatever x is, plus 8.0 millimeters. So here's what that means. Say I took an x that was equal to 1. So at x equals to 1, I should be able to calculate this value right here using this equation. Okay, so it'd be 1 times 8 millimeters per second, right? So that's 1 second times 8 millimeters per second. That would give me 8 millimeters, plus the 8 millimeters over here should give me 16 millimeters, which is approximately what I get over here. So anyway, that's how to graph manually. And again, this is not going to be perfect. The better way to do it is you input this data into a least square fit program, and you have the calculator or computer calculate it for you. But that's the basis of how we do that.